A little walkthrough for activity, linear correlation, confidence intervals. Right, so the example, the cost of mountain bikes, this is a familiar one. We did this before when we were looking at linear regressions. Cost of mountain bikes are given in the following table, along with overall rating scores given to each bike by Consumer Reports magazine. Find 90, 95, 90%, 99% confidence interval estimates for the population slope between rating and price. Right, so there's a relationship between slope and correlation. If the correlation is equal to zero, then the slope is equal to zero, and vice versa. So by making a determination about the slope, we're also making a determination about the correlation. We're looking for not just whether or not there is a correlation number, a correlation coefficient, but whether that number is significant, right? So we first figure out the responses to this table. Fortunately, it's only one calculation, so I'm going to go into that first cell. All this stuff is pre-populated for you, the labels, but you may have to do that on your own because it doesn't come with the calculation I'm about to show you, so you may have to refer back to this for other assignments. So E equals LINEST, all right? And then we select our Y column, top to bottom, comma, our X column, top to bottom, and then we type in true and true, and that'll populate the table for us. If the structure, the format isn't what you would like, then you could adjust it by changing the font, reducing the font size. You could also change the number of decimal values, just kind of make it a little nicer. All right. So we have this information all populated. You see the one command populated the entire table. So I'm going to do my 90% confidence interval. So this is a T interval. So E equals T inverse, T dot inverse 2T. My alpha value is 0.10. My degrees of freedom is going to be however many pairs of data there are minus 2. So I'm going to do a count. I mean, you could physically count too if you want, but I'm going to count, or let Excel count, Google Sheets count, and subtract 2 from that, right? In previous cases it was minus 1, but because these are two variables, we're subtracting 2, 1 for each variable. So we lock that in. That's good to go. I'm going to throw some dollar signs around this, because I'm going to copy this down the line in a minute. And I don't want to have to change too much. Now your low bound is going to be equal to the coefficient for slope minus the critical value times the standard error for the slope. You see it says standard error for coefficient, but it corresponds with the column for slope. We actually only need these two pieces of information to do our confidence interval, right? So I'm going to put that in. I'm going to throw some dollar signs around the things that I don't want to change, which would be F7 and F8. Lock it in. I'm going to copy it over. Change minus to a plus. I'm going to copy this down the line. We'll worry about conclusions in a minute. So this one is now 0.05. This little typo here, hold on. This one is going to be 0.01. Oops, copied the wrong thing. Where am I? Copy this, put it here, and change 0.05 to a 0.01. All right, I should be able to just copy these across, make sure it's pointing to the right stuff. It is. Verify this one also, looks good. One more time. All right, see it's pointing to the right things in both cases. So we are in good shape. All right, so I'm going to draw a conclusion. We are, the first one is 90% confident that the population slope is between the low bound and the upper bound. So 0.030, the y variable is rating. Rating is measured in score. So whatever the score is like a point or something. I'll say points per dollar. Copy that, so I don't have to write it again. And 0.052 points per dollar. All right, same idea for the remaining ones, just changing a couple things. You could use the concatenate function also if you want. Up to you. In this case, it's not too much trouble to just do copy paste. And 5, 5, a couple little edits here and there. And then this one's 99% confident. And we're looking at 023. You can see how the interval's getting wider and wider as we go. And 05, I'm looking at the wrong thing, I think. 059. All right. So our low bound started at 0.03, then it went to 0.028, now 0.023. All right, and the high bound expanded 0.52, 0.52, 0.55, and 0.59. All right. The rule here is if 0 is not in the interval, then there is a significant linear correlation between the variables. All right. So 0 is not in any of the intervals. So there is a significant correlation between, and we will be specific here, points or rating and price. All right. Points were the units, so we'll say rating and price. Now, does that mean one causes the other? Not necessarily, but it does demonstrate that at a statistical level that there is a correlation and that is worth investigating further. All right, so that's the example. You move on to the assignment, which has the same structure. And as usual, share, anyone with a link. We want editor, and then copy the link and submit it. All right.